Now let's try question number 6. It's on gradient and equation of a straight line. So for question number 6a, right, you can see this graph over here, right? We have two straight line AB and straight line AC. So the question on part I, right, A part I is asking us to calculate the gradient of AB. So in order to calculate the gradient of AB, right, we need to take the rise, which is over here, okay, over the run. Okay, so over here the rise is actually, so this is 5, right? So 1 2 1 2 3 4 5 6. So the rise is 6, and then the run is from -2 to 6. In that case, that will be 8 unit. So we have the rise over run. So gradient AB, right, is actually equals to rise over run. Now because this line AB, right, has a positive gradient, so we can just take rise, which is 6, over run, which is over 8. So we get 3 over 4 after simplifying it. So that will be the gradient AB. Now let's do 6b. Write down the equation of BC. So what is the equation of this BC over here? So it's actually a vertical straight line, right? So it cuts through the x-axis at x equals to 6. So the equation of BC is actually x equals to 6. Okay? 6c, find the area of triangle ABC. So we need to find the area of triangle ABC over here. Okay, so find the area of this triangle ABC over here. So actually this is something that we have done in our primary school. So the base, the length over here is actually 3 units. And then the height over here, which we have found earlier, is actually 8 units. So the area of triangle ABC is equals to half times base times height, okay, which actually is equals to half times 3 times 8. Okay, so this is half times 24, which is equals to 12 units square. Okay, so when the question never tell you the unit, right, the length, the area will be represented as unit square. Okay, so now let's move on to question 6b. The equation of a function is y equals to -1 over 3x plus 2. Okay, so let's do 6b part I. Find the value of y when x is equals to 3 over 4. So what we're going to do is we're going to substitute x equals to 3 over 4 over here to get the y. So y equals to -1 over 3 times 3 over 4, because we substitute this x with 3 over 4. Plus 2, so this is equals to -1 over 4 plus 2, which is actually equals to 7 over 4. Okay, so that is for 6bi. Now 6bii. Find the value of x when y equals to -1. So over here, we are going to substitute -1 into this y over here. So -1 equals to -1 over 3x plus 2, which means I bring this over here, 1 over 3x, and then I bring -1 over here, equals to 1 plus 2. So remember, when you bring the terms from one side of the equation to another, remember to swap the sign. So here I swap from minus to plus. Same goes for the -1, I swap from minus to plus. So 1 over 3x equals to 3. So here I'm going to times 3. So over here I also must times 3. So 1 over 3x times 3 is x, and then 3 times 3 is 9. So x is equals to 9. Okay? So actually, what we are doing here, we are actually finding the coordinates of the points on the line. So over here, what this means is that this point here with coordinates 9, okay, and -1 is on the line. Okay? So that's essentially what we are doing. When you substitute y equals to -1 here, right? And then you find the value of x, right? Essentially speaking, over here we got that x is 9 and then y is -1. So we are actually finding a point on the line with coordinates x as 9 and y as -1. Okay, so the question here asks, explain why 7 minus 1 does not lie on the line. Okay, well that's because when your y equals to -1, x equals to 9, and x is not equals to 7. Okay, so in that case, okay, when y equals to -1, x is equals to 9, and x is not equals to 7. That is why 7 minus 1 does not lie on the line. Okay? So that's pretty much it for question number 6, B part 2.